So I'm going to work a bit more on the parser. One of the things I want to do is start parsing functions, but before then there's a couple of things to fix in the test code. So in the parser test, as I walk the AST, I execute tests that I have found in the source. But there's no way for me to know if I'm actually executing all of them. So for example, if I run these tests, they all work just fine. But if I go to the expressions test and I change this to I'll attach this comment as leading trivia to the plus token. And now if I rerun this, it still passes. But this test isn't actually being run because I'm only looking at the start offset for an AST node, which is going to be this one. This plus never gets, we never query it for any trivia. That's fine because it's a bit strange to have a comment here anyway. But I do want to check that I'm actually running all of the tests. So I think that the way that I'm going to do that is to just save this out into source. I'll keep a variable of want test count, and this will be the count in source that I see of that test prefix. So we've got want colon, and then we'll also keep a got test count. And I'm just going to increment this every time I actually run a test. So now if the want test count does not equal the got test count, I can generate an error. Want this many tests, got this many. So now if I test, oh, not enough arguments. Oh yes, okay, I need to pass in the source. So now if I test, we get the error want one tests got 0 because I'm not running any of them. So if I put this back on the on the integer token up here, now it passes because it's actually running the test. So that's the first issue. Next is that I need to start generating errors in the parser. So for example, if I have some test data in an error folder, and I create one called unknown token, this should generate an error. So for example, unknown token generates error, and then we'll have some unknown token with a semicolon on the end. So running this test should generate an error from the parser, and the way that I'll do that is by just checking to see if the test starts with the error directory. So parse needs to return an error. And we need to say if strings.has prefix, so we'll check on the test case and see if it starts with error slash. If it does, then I expect an error to be happening. So we'll say, and we always run a return from here because there's no point in trying to run any AST tests. So we'll say if the error is nil in this case, then we'll error to say want error got nil. Then in the success case, if there was an error, that shouldn't be happening, so we'll just say t.fatal error for that one. It would also be useful to actually have a test name here, so I'm going to make this test case the test name. So we'll do t.run tc, and then we'll say t testing.t and just wrap this in this function here. So this one can go all the way down here. So the parser parse function now needs to return an error, if there was one. So that means I'll put this into a variable called node, and we'll return node nil, and I'm going to keep the errors as a slice of string. So we'll say slice of string, and because I'm returning based on the errors, I'll basically just do if the length of p.errors is greater than 0, then we'll return nil and the error. So I need to generate an actual error here. The error will be errors.new strings.join, and we'll join p.errors with a new line. So each error goes onto a new line. And if I'm keeping errors, I need to reset that state every time I parse as well. While I'm in here, I'm going to change all these make functions into parse functions, just for consistency in naming. And since I'm resetting state in parser, I should actually go check the state in scanner, because when I scan, I set the file and then I reset tokens on the file, but the file actually has more state now. So I think I'll just do s.file.reset. File can have a new function reset. And in here, we're going to reset everything that's not name and source. So these two map ones can go down here and be wrapped in a call to clear. And then these slice ones can just set to nil. So that takes care of resetting the file state. The scanner state is all okay. But when I see a new line, I think I should actually be resetting the last non-trivia position unconditionally. Because otherwise I could end up associating a leading trivia with the previous non-trivia token that was from the previous line, so it would end up as being an inline trivia. So this should fix that. So that's state and everything taken care of. So now I need to actually generate some errors and see if it works. So if I run this at the moment, p.error is undefined. Okay. Errors. Cannot find unknown token.fin. Error slash unknown token.fin. I'm missing an N. Okay, so right now I get this nil pointer dereference. This is for the unknown token.fin test. And the reason for that is because I'm immediately trying to parse expression, and the unknown token is being treated as a prefix function, which I call, but that rule doesn't exist, and even if it did exist, it doesn't have a prefix on it. So we're trying to call a function on a nil pointer. So I should be saying if rule.prefix equals nil, then I want to generate some error and return something else. So I want to say, for example, p.error, pass in So we'll pass in the offset that the error happened at, so this will be p dot next dot start. Then I think we want to pass in a format string. So we'll say, for example, unexpected token this. And actually, it would be nice to have a bit of a more descriptive error message here. So rather than unexpected token, let's just see what can start what can start an expression is either an integer literal, a unary prefix, or an identifier. So perhaps here I should say expected identifier, literal, or unary prefix. Found this, and we'll pass in some lexeme. So we'll get the lexeme, which will be p.file.lexeme, and we'll pass in p.next.start to p.next.end, because that's what I want to put in the error message. We generate the error, then I need to try and recover from this error as best as I can so I can carry on parsing and generate as many useful errors as possible. So we need to go to some synchronization point, or some token that we'll use as the synchronization point. And since we're requiring statements and things to end in semicolons, the semicolon makes the most sense to skip to, basically. So I don't want to return nil from this because I want all of the ASTs to have valid AST node types. So I'm going to create a new type called ast.bad. And bad will basically mark the start offset to the end offset of wherever we skipped over. So we'll say, for example, parse bad until token.semicolon. Then we'll return bad, but if we're on the semicolon after this, we want to skip the semicolon, so we'll say p.advance. And it'd be nice to create some other helper function here that can take in what I expect. So I'll say consume a semicolon. So consume will do the same thing as advance, but it will also check what the next token is, and if it's not that thing, it will generate another error. So we need to create a couple of helpers here. I think we'll start with consume. So consume is going to do exactly the same thing, but it's going to take an expected kind. So we'll say if p.next.kind does not equal expected, then we'll generate an error to say p.next.start. And actually, this is going to be pretty much the same as this. We're going to have lexeme here. But we're going to this is going to be a generic one. So this will be unexpected token. Here, expected. Or we'll say, we'll change this around so it's consistent with the order. We'll say expected this, found this. So we expected token kind there. And we don't need to quote this, I don't think, where this can just be a normal string. Found something in quotes. So we'll say, this is lexeme. I'm going to change this to found. I'll do the same thing up here, just so it's a bit clearer what this variable is for. And then it's just going to advance, so we'll always advance, but the only difference is that we automatically check for an error if we've got some unexpected token. So we actually need the error helper now. So error is going to take an offset that we found the error originated from, some format string, and some args to pass in to like sprintf or something. So we'll start by having an empty string message. If p.file.name exists, then we'll start the message with that. So we'll say message plus equals p.file.name plus colon. Then we'll query the line and column for the offset. So this will be p.file.linecol. At the offset, then we will add those to the message. So plus equals strconv.I to A line plus colon. We'll also do the same thing for column. And this will have a space after it as well. And then message plus equals fmt.sprintf, pass in the format string along with all the args. And then we can add it to the errors. So errors equals append p.errors message. We need parse bad until as well. I'll put this one down here. So we're basically just going to say we'll take the start, which is p.next.start, return ast.bad. So this will have a start, and it will have an end, which will be p.next.start as well. So we're just going to say for p.next.kind does not equal until. So until will be parsebed until token.kind. Then I think I can just return the pointer to this because I'm not passing it into one of those functions. Maybe I might have to change that back to AST node. So while we're not on the thing that we're skipping until, and the p.next.kind does not equal token.eof, we'll just advance. So now we need the bad one. So in here we'll have bad. That's bad. Change the I to B. That's all the same. I need to add it to the print. For print, I'm not going to bother printing out the entire lexeme here because there's no point. I'm just going to return bad with parentheses around it. And I need to add it into walk, and this is a leaf node, so I don't want to do anything with it, so we'll just skip it. And that passes. Maybe I should make it fail to check I'm actually doing the right thing. Let's say 1, 2, 3 here. That shouldn't be passing. Let's see, so I've got parser test. Let's just call t.error with tc and error. So expressions gets back nil, and then unknown token gets back, error unknown token line 2 column 1, expected identifier literal or unary prefix found empty string. And then we also get expected semicolon found empty string as well. So TC should have this prefix. And it is erroring. But I don't know why it's giving empty strings as in the error message. So we've got parse expression here. Let's just print out the kind. So we've got int and then EOF. Parse expression, int. Let's just go print it out in here. So yeah, in this case it's saying EOF, which makes sense for the empty string here. But in the error unknown token, we do have a semicolon here as well. So it is parsing, it is doing, so if I parse bad until semicolon, and then I print the kind, I still get EOF after, before the semicolon here. And if I get rid of this, we get the one error. So is this resetting state correctly? We're resetting the file, the position, and the errors, and then next get set by... okay. I think this is because I need to explicitly set p.next.kind to token unknown. Okay, one error got nil now, so that's correct. That's what I'd expect from the unknown token one. So now if I change this to a bunch of @ signs, now we get the error, which is what I would expect. So if I go to parse the test and allow this to actually complete, so now it correctly passes here, and then in unknown token, if I change this to 1, 2, 3, now it says that we want error but got nil. So that's correct for error cases. So we're handling error cases when needed, and we've got expressions here, but this should also really be an error because it shouldn't be a top-level expression. Instead, what I want to do is have some function. So we want function expers, and in here we will do the tests. So we'll basically put this in here, and I expect this one to pass with a semicolon on the end. Then in error, we can do, say, for example, top level expression. So, 1 plus 2 multiplied by 3. This should error. And this one shouldn't error. So we're going to go to parse the test. We'll put in the top level expr. Okay, so expressions now errors because it's trying to find an expression, but it's finding function instead. And then top level expr wants an error, but it got nil. Okay, so we can fix this by parsing functions, basically. So to parse functions, I need a few extra AST nodes. One of them is going to be a function declaration. We're also going to need, I'm going to call each file a module, and a module will be made up of declarations, which will be just nodes for now. So a function declaration just needs, let's say it's got a start, because I want to test these, so I need to start offset. It will have an ident, which will be a pointer to ident. We're going to have parens. I could keep the offset of the parens so I can attach trivia to them. But right now I don't care about making tooling like formatters and things, so I'm going to leave that off at the moment. Then we need a body. So body is going to be some block statement. So we've already got idents down at the bottom here. So I just need block statement. And a block statement, we're going to keep the start offset and the end offset. And then in the middle, we're going to have statements. And this is also just going to be a bunch of nodes. I think that's about it. So yes, I need to implement the node interface on each of these. So we've got M module. So module is going to be the span. It depends on how many declarations there are in here. So we'll switch on the len of m.decals. So if we have none, then I'll just return 0, 0. If there's 1, then we want to return the span of that 1, so m.decals 0.span. If there's any more, that will be default, and so in that case we're going to do this start and end thing. So we'll have m.decals 0 for the start one, and then this is going to be len m.decals -1 for the end one. A function declaration just needs to do, so this is, let's say, f function declaration. This one just needs to do f.start until f.body.span is the end. Okay, so that's why we keep the end here. And we'll just assume that there's a body at the moment. A bit later we might allow no body for things like foreign function interface and stuff like that, but right now we'll just assume there's always a body. And then the last one is going to be block statement, and this will just be returning the b.start and b.end. So now if we go to the parser, let's go to expression. So let's add another one here called decals.fin, and I'll change this one to be called expers.fin. And now in the parser test, we'll change this one to be expers, and we'll have another one called decals. Okay. Okay, so in decals.fin, I'll basically have function main, let's say. Oh, we'll just say foo here maybe. And we'll leave this one empty. So we'll just say want some function. So I'll put this on another line. We'll say function foo, and then we'll basically have an empty block. Actually, I'll just leave this on the same line here. So that's what we expect for printing those AST nodes. And then the expers one just has a function so that I can run the test without erroring. So I actually need to add these to print as well. So when I print a module, we'll go over all of the decals. So we'll range over m.decals, and we'll build up all of the strings. So we'll say string, and then we'll return all of these as, let's just say mod space. I don't know. We'll do string strings.join. This doesn't have to be efficient. It's just for testing and things. So we'll say strings.join. If string does not equal nothing, then we'll add a space. String equals space plus the string. Then we'll add that onto the end of here, and we'll add a closing paren. Okay, so we've got mod. This is pretty much going to be the same for block statement. Oh, I actually need to print some stuff. So stirs equals append, stirs sprint decal, and we'll pass in file. Okay, so this is going to be basically the same thing, but instead of decal, it's going to be a statement. This is going to be statements, and we're going to do node, and this should also be node up here. And then we'll do the same thing. We'll just say block instead. Then we've got a function decal. So a function decal is going to return fn. We always expect there to be a name, so we'll add the name as well. This will be the name, or we'll call this ident maybe. And then we always follow it, at the moment at least, with a body. So we'll say ident equals sprint node.ident, and then we'll have the same thing for body down here. Body. Okay. Then we need to walk as well. So module is going to just loop over each decal. Range over node.decals. Walk decal pre. Basically the same thing for a block statement, but this is now a statement, and these are statements. And then for a function decal, we'll walk by just doing the same thing but with the body. So this will be node.body, and we'll pass in pre. Okay. Not enough arguments in sprint. So we've got sprint. Yeah, down here I need to pass in the file. Okay. So now we can start parsing the function. So if we go to the parser, I'll start by just creating a module here. So we'll say var mod is an AST module. And we're gonna return the pointer to that module. So what we'll do here is say for p.next kind is not EOF, we're gonna try and take a decal by calling p.parseDecal. And then we'll just add it to the slice of declarations. So we need parse decal down here. Decal. So we can just do a switch on p.next.kind. If we see a semicolon, actually I'll leave this for now. What we'll do is we'll say if we see a token.function, then we'll just return a p.parse function decal. In the default case, we'll return p.parse bad until, and we're going to skip until the next function token. So now we need parse function decal. Function decal. So this one, I think I can just return an ast.functionDecl pointer here. So we'll start by saving off the offset because we need that. In fact, let's just return ast.functionDecl. What I need in here is the start offset. I need the ident, and I need the body. So say p.next.start, p.consume token.function is what we expect. What's the next thing? The next thing will always be an identifier at the moment. So we'll say ident is p.parseIdent. Then we need a body. So we'll say body is p.parseBlock statements. And then that should be it for the function parsing. So we need a parse block statement now. And p.parseBlock statement is going to bring back an ast.block statement. So we need the, well, let's return ast.block statement. This needs a start, an end, and statements. So start is going to be p.next.start. Then we want to consume a left brace. At the very end, we want to consume a right brace, and end is going to equal p.next.start at this point. Then in between here, we want to parse statements. So we'll have statements as a slice of ast.node. Now for p.next.kind does not equal token.rbrace, and p.next.kind does not equal token.eof, we will try to parse out a statement. So we'll say statements, statement is p.parse statement, and then we'll just fill up this slice. So now I need to parse a statement. So in this case, I want to say switch. Actually, in this case, I only have expressions right now, so we'll just parse an expression with power none. Then we expect there to be a semicolon, and then we'll just return the statement as it is. Undefined EOF, so EOF should be token.eof up here. Line 95 cannot use, okay, so parse ident is used in the parse expression call, which is why it returns a generic ast.node. So I just need to type assert this, which I can do safely because it always returns a pointer to ast ident. Okay, so now we've got a load of errors. Expected, yes, okay, so when we're parsing a function, we also have parens that we need to skip. So we do the ident, then after the ident, we want to consume a token.lparen and an rparen. We won't have any parameters right now. Yes, I am printing out, so what I want to test for is function foo block, but I'm getting mod function foo block because the start of the function in that test, that offset also matches the module start. So it's printing the module one instead of just the function. So I don't actually want to print the entire thing here. So I'll leave this print in because it's useful for debug. So I think actually I'll change the parser test. And within the walk for the test, I'll say that if if the node is AST module, then we'll skip it. We won't do anything. So that will allow all of the tests to run individually on things like functions. Okay, so top level expression, one error got nil, and unknown token also says one error got nil. So that is because in the parser here, when I try to parse a declaration, I parse bad until, but I don't generate any errors. Okay, so we want an error at p.next.start, and this should be something like expected declaration found, and then we'll just put in the lexeme again. We'll call this found again, so we'll just take this. And everything passes. So I think that's it for this time. I'll just have to decide what to work on next time, but probably more functions. Need to add parameters and things like that. Parameters, return types, variable declarations, return statements, and then I think after that I can move on to a simple type checker.